So now we're going to be looking at special right triangles. Special right triangles are triangles that are going to have specific angle measurements. So when we look at this first one, we're first going to do a 45, 45, 90 triangle. Okay, and that's all. Every time we'll say it, we'll be like, oh, that's a 45, 45, 90. Okay, that's what you call it. It doesn't have a special name. It's just called by what its angles are. Okay, and up here it just mentions that a 45, 45, 90 is just a triangle that's formed when we cut a square in half by its diagonal. And so when we look at a 45, 45, 90 triangle, its side lengths have certain relationships, okay? And this is based out of Pythagorean theorem. It's how you can solve for it, okay? But in this one, we have x are our legs, okay? Remember these ones that are on the sides? This is what's called our legs, okay? And then we have our hypotenuse is the x square root of 2. Oops. So we have hypotenuse, okay? Remember, our hypotenuse is also like our C, so it's the side that's across from our 90-degree angle. So the legs next to our 90 are x and x. The side across is x square root of 2. So when we look at a problem, okay, the first thing that I'm going to do is I'm going to go ahead and just look at these different side lengths. And what I always do first is I label which ones are my xx, which one's my x square root of 2. Okay, so in this one, across from my right angle, I am going to put my x square root of 2 here on the outside. And then my legs, I'm going to put my x and my x. And so what happens in these kind of problems is, one thing is that gets confusing is if they already have an x, okay? Well, I can always use any variable. So if I want to change this to the y square root of 2, I can. So like in this problem, it might be better to say, okay, my side lengths are going to be y square root of 2. Okay, and the reason for that is I'm going to equal these to whatever the side length is. So I'm going to have up there on the top right, I have 8 is equal to y, and then I have x is equal to the y square root of 2. And so when I write it like this, well, as you can see, we said that y is already 8. So all I have to do is substitute, and I'm going to get that x is 8 square root of 2. I'm going to double check that it's simplified. In this case, it is. And so that's going to be my answer. In the second one, I'm going to do the same thing. So, again, they use x's, so I'm going to say the y square root of 2. Okay? And so when I do this, x is equal to my y. Okay? And then my top one here, I have 5 square root of 2 is equal to y square root of 2. So now to solve for my y, I'm just going to divide by this square root of 2 to get rid of it. So this side it cancels, so I get y is equal square root of 2 on this side cancels as well, so I get y is equal to 5. So that tells me if I substitute that x is also equal to 5. And we're done. Make sure that you do the monitoring progress. I'm happy to just help you. We can show you some different ways on this. But you just have to remember the values, okay? Anytime, with this one especially, if you already have one of these leg lengths, all you have to do is just add a square root of 2 to it. And that's all you have to do. Like I said, this one, all I did was add a square root of 2 if I'm trying to find the hypotenuse. If I was trying to find the other leg's going to be exactly the same length, so I'd have 8. And then, like I said, this one is the 8 square root of 2. This side, since I already have something with the square root of 2, this side's a 5, and that side's a 5. The other kind of triangle that we have is a 30, 60, 90. Okay, so 30, 60, 90, again, it's just another type of triangle. Instead of 45, 45, we have a 30, 60. And it has another relationship length. So its hypotenuse is always going to be 2x. As you can see over here, this is my hypotenuse. This is like my C. Okay, and then my leg lengths, the side that's next to my 30, since I already have a 3 over here. Okay, notice I have this 3 here and 30. That's going to be my side that has my 3, my square root of 3. And then my 60 is just going to have x. Okay, so there's my x, just like in the last one where we just had an x. But this time I have the square root of 3 with my 30. Since they're both 3, they match up on the same side. And then my 2x is always going to be my hypotenuse. Okay, and you're more than welcome to just have these diagrams and just make sure you just rewrite them out. So in this one, if you notice, I already have an x and a y. Okay, so let's change our variable again. There's no reason why in my 30, 60, 90 triangle, like I said, in this one, so like if this is my 30, this is my 60. Before we had, where this is x square root of 3, and this is 2x. Well, I can make that x anything. So let's change it, and let's say, okay, well, we're going to make these into whatever variable you want. If your name starts with a T and you really like the letter T, do a T, okay? I'm just going to put an A in here instead. So if I do A, I have 2A here, I have A, and I have A square root of 3, okay? So my 30 side is the one that has a square root of 3, so I'm going to do A square root of 3. My 60 side is just the A by itself. And my hypotenuse, the side across from my 90, is my 2A. Okay, or like I said, originally it was X on all those, but I just changed it to whatever letter I wanted. And so I'm going to set these all equal to whatever the value is that I wrote out there. So I have 2A is equal to Y. I have 9 is equal to A square root of 3. And I have X is equal to A. So I'm going to start with the one that doesn't have multiple variables, this one in the middle. So to get A by itself, I need to divide by the square root of 3. So I get A is equal to 9 over the square root of 3. Remember, though, that we don't like those radicals in the bottom. And so that word where we change it is that we're going to rationalize it. Okay, so if I rationalize, I'm going to multiply it by that radical in the top and the bottom. So I get 9 square roots of 3 over the square root of 9, which the square root of 9 is 3, so I get 9 square roots of 3 over 3, but my 9 over 3 reduces, 9 divided by 3 is just 3, so I actually get 3 square roots of 3. Okay, so all this written out, I get A is equal to 3 square roots of 3. And so now I'm just going to substitute that in for each of these. Okay, so I get down here, I have X is equal to A, so 3 square roots of 3. That one's done. And then at this top one, I'm just going to plug it in again, so I have 2 times 3 square roots of 3 is equal to Y. I'm just going to simplify, so I get 2 times 3, so I get 6 square roots of 3 is equal to Y, and I'm done again. There's my answers. Again, make sure you're doing the monitoring progress as you go along. So the next one, we have another problem. We're going to have one that's more like real life. It says we have an equilateral triangle, and it says estimate the area of the sign by finding the area of the equilateral triangle. So if we have an equilateral triangle, I'm just going to redraw my triangle over here, okay, just so it's not red in the middle like it is. Okay, so equilateral means all the sides are the same, right? It also means all the angles are the same. So if they're all the same angle, 180 divided by 3 gives me 60 in each one. Okay, but in order to try to use like my 30, 60, 90 or my 45, 45, 90, think about if I split this down the middle to make this right triangle here, and that happens in an equilateral. When I go straight from the top to the bottom, just go straight down, it gives me 2 right triangles, and it's going to cut this angle in half. So I'm going to get a 30 here, and I'm going to get a 30 on the other side. And I also need that to find the area, right? I would need to do base times height, in which case, like, this would be my base, this would be my height. So first, we need to solve for that middle portion. So I'm just going to erase half this triangle now. And if I were to erase half of it, now I need to divide 36 by 2. So 36 divided by 2 gives me 18. So again, I'm going to erase this so we just don't have so much on this page. So I have my right triangle here, and I have a 30 and a 60. So I'm going to label it. Remember, my 60 is just my x, my 30 is my x square root of 3, and my hypotenuse is my 2x. So I'm going to set all of those equal. So that one side, I just have x square root of 3. That's the side I'm looking for. Remember, this is my height that I need. So let's do our height. So our height is equal to the x square root of 3. Nothing to do there yet. I have 18 is equal to x, and I have 2x is equal to 36. No matter which way I do this, if I go ahead and solve this one, I'm going to get that x is equal to 18, but I already have that written down. So when I plug it in, My height is equal to 18 square roots of 3. So now, if I go back to my original triangle, my height here, remember we said triangles are just 1/2 base times height. So if I do, this is my base, there's my height. My area, like I said, is 1/2 base times height. All I have to do is plug it in. So my base up there would be my 36. My height, we just said, is 18 square roots of 3. So we're going to simplify this. So if I do 1/2 times 36, that gives me 18. And so then I have 18 times 18. And so it gives me 324 square roots of 3. The square root of 3, I can't simplify any further. So my area of my equilateral triangle is going to be 324 inches squared. So then in this next one, we have a scenario where it has a platform that's used to unload the trucks. And it says, how high is the end of the 80-foot ramp when the tipping angle is 30 or when the tipping angle is 45? So we're going to solve this twice. So let's start off. We're going to start off with the first one it gave us, the 30. Okay, so my tipping angle, it says, is this right corner. So this one, at first time, would be 30. And we want to know the height. They told us the ramp length is 80. And so now let's use what we know about 30, 60, 90. So our 30 side is our x square root of 3. Our, what would be our 60 side, because remember, they add it to be 180. So that side is going to be 60 degrees. This is going to be just my x. And then my hypotenuse side is my 2x. So I'm going to set them equal. So I get x is equal to h. And I get that 80 is equal to 2x. So to solve for x, I'm going to divide by 2. So I get that x is equal to 40. I'm going to plug this in. So my height is equal to 40. So in the first example, my height at the end of my ramp is going to be 40 feet. Okay, not bad. Now we're just going to do the second example. So my setup's the same. Okay, I'm just going to erase this stuff. My angles are changing though. It says that my tipping angle is 45. So that means that this angle is going to be 45. That means the other angle would also be 45. I'm still looking for my height, and my ramp is still 80 feet long. So now for a 45, 45, 90 triangle, remember we do x, x, x square root of 2. Okay, my hypotenuse is the only one that's different. So I'm going to set these equal again. So I have x is equal to h again. And then I have 80 is equal to x square root of 2. So I need to divide by the square root of 2 to get x by itself. Remember that we don't like those radicals in the bottom though. So when I write this, I have 80 over the square root of 2. I'm going to multiply my radical on the top and the bottom. So I get 80 square root of 2 over the square root of 4. Square root of 4 is 2. So I get 80 square root of 2 over 2. 80 divided by 2 is 40, so I get 40 square root of 2. And so my x, when I plug it in up here, it means my height is going to be 40 square root of 2 is my exact answer. Okay, so I could put here that 45 is going to be 40 square roots of 2 feet. If you wanted to know just about what that approximation is, leave it in the exact answer because it did not say to round to the nearest decimal. It did not say to take it out of radical form, so we're going to leave it. But if just for your own curiosity, you can do the square root of 2 times 40, and that means at this time the ramp height would be about 56.57 feet. Okay, it's going to be even taller when it doesn't have that 30-degree angle, and it has a 45 instead.